When it comes to adding and subtracting, unlike radicals that have large radicands, it's really important to look at them through the right lens in order to make this a little bit simpler. And the best way to do that is to look for multiples of perfect cubes or perfect squares, depending on what your index is. Here, if I'm looking for a cube root of 40, 8 is a perfect cube, and 8 is a factor of 40. So for me, I started with the smaller of the two numbers and tried to find a perfect cube factor of it. So I'm going to re-express the cube root of 40 as a cube root of 8 times 5. Now, I'm going to be adding 6 times the cube root of 135, and I'm going to be looking for either an 8 or a 5 in there. So if I were to factor a 5 out of 135, so basically take 135 and divide it by 5, right? If you wanted to look at that, 135 divided by 5, that would be 27. So this is really 27 times 5. Well, 8 is a perfect cube, just like 27 is a perfect cube. So by finding the perfect cube factor here and the remaining factor that was left, I was able to divide this number by that same remaining factor that was left to find an additional perfect cube. So use this first number in the way that you can simplify it as a clue to help you simplify the second piece. So the cube root of 8 is just 2, and then we're left with the cube root of 5, plus 6 times the cube root of 27 is 3, times the cube root of 5. So 6 times 3 is 18. So 2 times the cube root of 5 plus 18 times the cube root of 5 would be 20 times the cube root of 5. So the first thing I did was simplify the cube root of 40 by looking for perfect cube factors of 40, the first of which was 8. 8 times 5 is 40, so I knew that the cube root of 8, which was 2, times the cube root of 5 would be a simplified version of the cube root of 40. Then over here, I used the fact that 8 and 5 were my factors here to see if I could find something divisible by 5 in here to reveal another perfect cube, which it did. The cube root of 27 is 3, so 3 times 6 is 18, times the square root of cube root of 5. 2 plus 6 is 18, or 2 plus 18 is 20, so 20 times the cube root of 5. Likewise, same idea here. I have two numbers that are perfect cubes, and I have numbers under the radical that are pretty large. So think of multiples of perfect cubes. Well, 128, that's really 64 times 2, and 64 is a perfect cube. The cube root of 250, well, that's 125 times 2, and 125 is a perfect cube. So notice how with each of these, I have a factor of 2 left at the end, so I'm going to have a cube root of 2 left over at the end. The cube root of 64 is 4. The cube root of 2 is still just going to be the cube root of 2. So I have 4 times the cube root of 2 minus 5. The cube root of 125 is 5. The cube root of 2 is the cube root of 2. So we really have 4 times the cube root of 2 minus 25 times the cube root of 2. 4 minus 25 would be negative 21 times the cube root of 2. So with each of these problems, with each of the ways that we look at this, it's important to look at the smaller radicand, simplify it first, and use its factors as clues to help you simplify the other one. But the key here is to be looking for multiples of perfect cubes as well.